Hey guys, it's your girl Aubrey back with another Aubrey's Learning Corner. Woo-woo! So, today we are in the topic space science. And today's topic is stellar distance. Now let's start reading. The stars. Like the sun, stars are huge spherical masses of gas that began radiating energy because of nuclear reactions occurring deep within their interiors. Stars do, however, differ greatly in size, luminosity, temperature, and composition. The smallest stars have a radius of about 10 kilometers or 6 miles. The largest have a radius of about 1 billion kilometers or 650 million miles. The nuclear reactions in the cores of stars can also be different. When the hydrogen in the core is depleted, stars can begin to convert helium into carbon and carbon into heavier elements. Because stars are so far away, it is impractical to use kilometers, miles, or even astronomical units to express their distances. One of the units used is the light year. Light's journey. 1 light year is equal to the distance light travels in 1 year. 9,461 times 10 kilometers, or 5,878 times 10 miles. Near and far. The closest star of the sun, Proxima Centauri, is about 4.5 light years away, corresponding to 284,750 AU. The most distant stars in our galaxy are more than 50,000 light years away. Whew. Back in time. It is interesting to note that when we look across huge distances expressed in thousands of light years, we also look back in time thousands of years. For example, quasars are at distance of billions of light years. When we examine them, we are observing phenomena that occurred not long after the Big Bang. Do you guys know when the Big Bang was? Put it down in the comments. Star formation. Stars began their lives due to the gravitational contraction of clouds of gas and dust. The collapsing mass heats up. The collapsing mass heats up because the pressure increases. This is exactly the same process that heats up the air in a bicycle pump when it is being used. After a while, the mass of gas becomes spherical and glows red. A protostar is formed. After a while, the mass of gas becomes spherical and grows. As the gravitational contraction continues, the confined temperature and pressure at the center of the gaseous mass initiates the nuclear reactions that supply the energy of a fully formed star. Star formation is an ongoing process in the areas of galaxy rich in dust and gas, such as the Orion Nebula. The heated dust clouds radiate strongly in infrared light. Several areas of active star formation have been photographed by means of the IRAS satellite. A star forms from a massive cloud of dust and gas. The cloud slowly rotates, collapsing in on itself due to its own gravity. As it shrinks, it rotates more rapidly, eventually forming a spherical clump, which continues to collapse. Measuring stellar distances. The basic way of measuring the distance to a star is by the trigonometric parallax method. As Earth moves around the sun, a star relatively nearby will appear to shift its position in the sky relative to more distant stars. The trigonometric parallax, geez, that is such a tongue twister, I had to search it up. The trigonometric parallax is half the total apparent shift of the star with respect to the background. The parallax of a star, then, is the angle formed at the star by the triangle formed between the star and each end of the radius of Earth's orbit. A parallax of 1 second of arc equals a distance of 1 parsec, or 3.26 light years. Spectroscopic parallax. The intensity of light varies inversely as the square of the distance. When we look at two stars of the same intrinsic. When we look at two stars of the same intrinsic brightness, but one is twice as far away as the other, the more distant star will appear 4 times fainter than the closer one. The intensity of certain absorption lines in stellar spectra depends strongly on the intrinsic brightness of the star. A star's distance can be derived by noting how bright or faint it appears. Parallax. By definition, a parallax of 1 second of arc corresponds to a distance of 1 parsec. Parallax of 1 second. The distance of a star in parsecs is thus 1/parallax, like this. 1 parsec is equal to 3.26 light years, like we said. The basics. Stars. Number. Perhaps more than 10 billion trillion in the known universe. Billion, trillion, that's an actual number. You know when you were kids and you were trying to express something that was like a huge amount? 1 billion, trillion, gazillion, bajillion, like that stuff like that. 1 billion trillion is an actual number. See, I never knew that. See, now when somebody's gonna be like, that's not a number, 1 billion trillion is in fact a number. Anyways, let's keep reading. Number of stars. Perhaps more than 10 billion trillion in the known universe. Age. Up to about 13.7 billion years. Most stars are from 1 million to 10 billion years old. Wow. Composition. As determined by mass, at least 71% hydrogen and roughly 27% helium. Oxygen and carbon account for most of the remaining mass. Mass. From about 1 to 10 of the mass. From about 1/10 of the mass of the sun to more than 100 times the mass of the sun. Largest known stars. Supergiant stars that have a radius of roughly 650 million miles or 1 billion kilometers, about 1,500 times the radius of the sun. Wow! Smallest known stars. Neutron stars that have the radius of approximately 6 miles or 10 kilometers. That is not much at all. Colors. Ranging from reddish for the coolest stars to yellowish for the warmer stars to bluish for the hottest stars. So red is coolest, yellow is warmer, and bluish is the hottest. Surface. From about 2,500 K, 2,220 degrees Celsius, or 4,000 degrees Fahrenheit, for dark red stars to about 50,000 K or 50,000 Celsius or 90,000 Fahrenheit. Yeesh. Wow. For the hottest blue stars. Core. About 10 million K, 10 million degrees Celsius or 18 million Fahrenheit in stars which hydrogen is using to form helium, to nearly 10 billion K, 10 billion degrees Celsius or 18 billion degrees Fahrenheit in collapsing stars that are about to produce supernova explosions. Wow. Energy source. Nuclear fusion that changes hydrogen into helium or similar fusion processes that produce heavier and heavier chemicals, elements up to iron. Alright, that's all I've got for today, but I hope you guys enjoyed today's Aubrey's Learning Corner. Always remember, it's cool to be a nerd. Nerds are smart. They learn so much just like you and I do on Aubrey's Learning Corner. Goodbye!